investment casting. Investment casting is a special casting process executed to produce multiple castings at a time. Investment casting is achieved by executing 5 steps. They are pattern creation, mold creation, pattern removal, casting preparation, and mold removal. To understand investment casting in more detail, let us cast a dumbbell-like structure using this casting method. The first step is pattern creation. For this, consider 2 aluminium dies that consist of cavity of same shape as that of the final casting product. Now inject some amount of molten wax into this die and keep it idle for some time. As a result, we get a solidified wax structure. This structure acts as a pattern for the casting process. Similarly, make multiple patterns. Now heat the bottom portion of these wax patterns and paste them on a single metallic bar. The next step is mold creation. For this, dip the group of patterns in a liquid of sodium silicate. Then take them out and allow the excess liquid to drain off. Now place these wet patterns under the dropping zirconium. We see that the zirconium grains get attached to the surfaces of the wet patterns and forms the coating of a small shell of grains over it. Repeat this process of dipping and coating with the increasing grain size for 5 days. Thus we get a thick shell-like structure. The next step is pattern removal. For this, place the set of coated molds in a hot furnace for about 2 to 3 hours. As a result, the molten wax gets melted and the wax pattern gets removed. The next step is casting preparation. For this, pour the hot molten metal into the vacant mold set till the molten metal gets distributed evenly in all the patterns. Then keep the mold aside for some time to solidify the molten metal. The last step is mold removal. For this, place the casting set on the vibrating hammer and supply electricity to it. As a result, the whole set shakes and the mold breaks into pieces. Thus we get the desired castings. Thus, investment casting is a special casting process in which casting is prepared by pouring hot molten metal into the mold, formed by coating refractory grains around a wax pattern, which is then melted out to leave the mold. It is also known as the lost wax process or precision casting. Investment casting is a casting method designed to achieve high dimensional accuracy for small castings. It is used to make parts which cannot be produced through normal manufacturing techniques, such as turbine blades that have complex shapes or airplane parts that have to withstand high temperature. Related terms are
hot chamber machines are used primarily for zinc, copper, magnesium, lead, and other low melting point alloys that do not readily attack and erode metal pots, cylinders, and plungers. The injection mechanism of a hot chamber machine is immersed in the molten metal bath of a metal holding furnace. The furnace is attached to the machine by a metal feed system called a gooseneck. As the injection cylinder plunger rises, a port in the injection cylinder opens, allowing molten metal to fill the cylinder. As the plunger moves downward, it seals the port and forces molten metal through the gooseneck and nozzle into the die cavity. After the metal has solidified in the die cavity, the plunger is withdrawn, the die opens, and the casting is ejected.
Different types. We know that pattern is used in casting process to produce a cavity in the mold, where molten metal can be poured. The shape and size of the casting produced is similar to the pattern. Hence, pattern is the replica of the casting. Thus, pattern is the model or replica of casting product. It is used to prepare cavity in the mold where molten metal can be poured and allowed to solidify. The four main types of patterns used for casting metals are single piece pattern, split pattern, cope and drag pattern, and match plate pattern. Now let's discuss each of these types one by one. Single piece pattern. This type of pattern is made up of only one piece. It does not contain any loose joints, and one of its surfaces is flat. Split pattern. In this type of pattern, the structure of casting to be produced is split into two individual parts. While the upper part is accommodated in the cope, the lower part is accommodated in the drag. The cope and drag molds are then prepared separately and assembled together to form the complete mold. The split surface of the pattern is present at the parting line of the mold. It is used in cases where it is difficult to remove the pattern from the mold. Cope and drag pattern. It is a form of split pattern, with integrated gating and runner system provided in the drag pattern, and integrated risering system provided in the cope pattern. Match plate pattern. It is a form of cope and drag pattern, where both cope and drag patterns, along with the gating and risering systems, are mounted on a single match plate. Here, cope flask is present on one side of the match plate, and drag flask is present on the other side. After ramming the cope and drag, the match plate along with both patterns is removed. The residual cope and drag are then joined together to form the complete mold. Related terms are sand. Molding sand used in casting process consists of three components: silica grains, clay, and water. Here, silicon grain is the major constituent which account for over 90% of molding sand. Now let us try to make molding sand. For this, we first pour a high proportion of silica grains and clay in a bowl. Now we mix them together thoroughly to get. Then we add some water in this silica clay mixture and mix them thoroughly to get a paste-like texture. This is our required molding sand. Thus, molding sand consists of three main constituents: silica grains, clay, and water. Now let us list some of the properties of molding sand. Permeability. The molding sand has high permeability or porosity to allow the easy passage of gaseous materials. Water and steam whenever molten metal is poured in the mold. It is achieved when the sand grain size is made coarse or fine and the grain shape is made round or angular. Cohesiveness. The cohesiveness or strength of the molding sand is high, due to which the sand particles stick together. It is achieved by mixing sand grains properly among themselves and with the clay. Plasticity. The sand particles acquire a predetermined shape whenever pressure is applied and retain that shape when that pressure is removed. It is achieved by using fine-grained sand particles and the correct amount of clay. Refractoriness. The molding sand has high refractoriness, that is, the sand withstands high heat without breaking down or getting fused. It is achieved by removing impurities, especially metallic oxides, from the molding sand. Note that chromite sand, zircon sand, and olivine sand are some other types of sand that can be used instead of silica grains. Related terms are Google casting. Centrifugal casting is a special casting process where the casting is prepared by rotating the mold rapidly about its central axis as the molten metal is poured into it. Let's understand the concept of centrifugal casting with the help of an example. Consider the setup as shown. As we can see, the setup consists of a steel mold attached to two top rollers and two bottom rollers. The bottom rollers are connected to a motor via shaft. Now when we turn the motor on, we see that the bottom rollers help the mold to rotate in the opposite direction. The rotation of the mold makes the top rollers to rotate in their opposite direction. Here the top rollers act as the backing support to the mold. Now introduce a spray gun and sprinkle some ceramic coating on the inner surface of the mold. The ceramic coating is sprinkled to facilitate acceleration of molten metal, produce high surface finish of casting, and to enable easy extraction of casting. And then bring a tray to its mouth. Then pour the molten metal in the tray in such a way that it enters the rotating mold. We see that the molten metal rotates rapidly. As a result, the molten metal moves away from the center because of the centrifugal force. And the unnecessary particles like slag and oxides, being lighter, move towards the center. Now leave the molten metal for solidification. Thus, after some time, we get the comparatively pure casting product. Some of the examples where centrifugal casting is employed are metallic pipe and cylinder liner. Related terms are casting. Permanent mold casting or gravity die casting is a special casting process where similar castings are produced in a metallic mold which can be reused many a times. Now let us try to understand how permanent mold casting is done. For this we need a molding setup shown as. The setup consists of two metallic mold halves which can be brought closer to each other with the help of wheels. Each of these mold halves consist of half part of cavity, runner and sprue. Also a core is provided in between the two mold halves to produce hollow castings. Note that the core can be withdrawn when solid castings need to be prepared. Now we need to follow the following step. The first step of permanent mold casting is mold preparation, where we heat both the mold halves. Now let us insert core pins in the slots provided in the core. Then we spray ceramic powder on the surfaces of the mold cavities, core and core pins to facilitate easy removal of the casting product from the metallic mold. Then we move to the mold assembly step. We see that both the mold cavities have provision for sprue in them. Now we rotate the wheels in the opposite direction to move the mold halves towards each other till they come in contact with each other, and a proper sprue has been obtained between their cavities. Then we move to the pouring step, where we pour the molten metal into the sprue with the help of a ladle. The molten metal is made to fall under gravity instead of allowing it to trickle down the cavity walls, as was the case in sand molding. Then we move to the cooling step, where the ladle is removed, and the mold is left undisturbed to allow the molten metal solidify inside it. Finally, we move to the mold opening step, where both the mold halves are separated and core pins are removed. And thus the casting is taken out. Permanent mold casting is used in bulk production of mechanical components like pistons, connecting rods, and cylinder blocks. Related terms are different types of mold. The different types of mold used for sand casting are green sand mold, dry sand mold, and skin-dried mold. Let's now describe each of these molds. Green sand mold is a commonly used mold which is freshly prepared from silica grains, clay and moisture. In this mold, the molten metal is poured immediately and the casting is taken out. It is used for rapid production. Its main advantages are that it requires less floor space, it is least expensive compared to the other two molds, and has less tendency for hot tearing of the casting. But its disadvantages are that there is a possibility of mold erosion, and it is likely to form blowholes and gas inclusions. Dry sand mold is a form of green sand mold which is completely dried by keeping it in an oven. Its main advantages are that it possesses higher strength than the green sand mold. It is less likely to get damaged during handling, and one can achieve better surface finish and higher dimensional accuracy from this mold. But its disadvantages are that it is likely to get distorted during the baking process. It is susceptible to hot tearing of casting and is more expensive than the green sand mold. Skin-dried mold is a mold prepared by drying only the skin of the mold cavity with which the molten metal comes into contact, instead of the whole mold. Its main advantage is that it is preferable for large-sized molds. But its main disadvantage is that it is expensive compared to the other two molds. Related term is
Cold chamber machines are used for alloys such as aluminum and other alloys with high melting points. The molten metal is poured into a cold chamber or cylindrical sleeve, manually by a hand ladle or by an automatic ladle. A hydraulically operated plunger seals the cold chamber port and forces metal into the locked die at high pressures.
We have already seen how casting is done. Here the molten metal is poured into the pouring basin, from where it flows through the sprue into the runner. Then the molten metal passes through the gate into the mold cavity. Excess molten metal flows out of cavity from the riser. The three main objects used in casting process are flask, pattern and core. Flask is the wooden or metallic frame used to hold the sand intact inside it. The upper flask is called cope and the lower flask is called drag. Pattern is the wooden or metallic replica of the final casting product. Core is the object kept inside the cope or drag cavity to produce hollow castings. In casting, three types of sands are used. They are parting sand. Parting sand is the sand sprinkled on and around the pattern placed inside the flask. Its purpose is to avoid sticking of cope and drag flasks. Facing sand is the granulated and filtered sand used to cover the pattern from all sides. It forms the face of the mold cavity. Backing sand is the unfiltered sand used to fill the entire flask. Its main purpose is to provide support to the facing sand. It can be reused in several casting processes. Now let us discuss some other terms associated with casting. Parting line is the line that divides both the flasks from each other. It is also the line between the two halves of the pattern. Cavity is the vacant space left in the rammed sand after removal of the pattern. Pouring basin is the small funnel-shaped pocket made at the top of the cope into which molten metal is poured. From here, molten metal reaches the mold cavity. Sprue is the passage through which molten metal enters the mold cavity from the pouring basin. It also controls the flow of molten metal being poured. Runner is the passage made along the parting line that joins sprue with the mold cavity. The molten metal flows through this passage to reach the mold cavity. Gate is the actual entry point at the runner from where the molten metal enters the cavity. Riser is the molten metal reservoir used to feed hot molten metal into the mold cavity when there is reduction in the volume of metal due to solidification. Mold casting. Shell mold casting is a metal casting process in which molten metal is poured into a mold of thin-walled shell pair made by applying sand-resin mixture around a heated metallic pattern. Now let us try to understand how shell mold casting is done. For this, we need to follow the following steps. The first step of sand mold casting is sand preparation, where we take a mixture of sand and resin in a vessel known as dump box. Then we move to the second step, which is pattern creation, where we take a half-split metallic pattern of the final casting product, which is flat from one side, and heat it to a high temperature. The flat surface of the heated pattern is then fixed with the lid of the dump box. Then we move to the third step, which is mold creation, where we place the lid on the dump box and invert the box upside down. This makes the sand mixture fall on the heated pattern. The resin of the sand mixture melts when it comes in contact with the hot surface of the pattern, due to which some sand granules stick on the pattern. Now when we re-invert the dump box back to its original position, we see that the unstuck sand falls down under gravity, while the stuck sand remains bounded to the pattern. Thus we see that a shell is formed by the layer of stuck sand around the surface of the pattern. Then we move to the mold assembly step, where we carefully remove the pattern from the shell. Similarly, let us prepare another shell of sand. Now let's join these two shells together. We see that a cavity is formed between the joined shells. Now let us place the shells in another box and fill the outer vacant space around them with sand. Then we move to the pouring step, where we pour the molten metal into the cavity between the shells with the help of a ladle. Then we move to the cooling step, where we keep the cavity undisturbed for some time to allow the molten metal solidify inside it. Finally, we move to the casting removal step, where we turn the box upside down, due to which the sand around the shells fall down. Now let us take out the shells from the box. Then we remove the shells to get the desired casting product. Related terms are defects. During casting process, several undesired irregularities creep into the final casting product. These irregularities are known as casting defects. Thus, casting defect is any undesired irregularity in the metal casting product. Casting defects are broadly classified into gas defects, molding material defects, pouring metal defects, and metallurgical defects. Now let's discuss each of these defects one by one. Gas defects. These defects occur due to the improper gas passing tendency of the mold. They are further classified into air inclusions, open blows, and blowholes. Air inclusion is air trapped in the final casting product caused by improper ventilation during casting process. They are controlled by choosing appropriate pouring temperature and improving gating practice by reducing turbulence. Open blows and blowholes are the spherical or elongated cavities formed on the surface or inside the casting. Due to the moisture present in the mold and core, or lower ventilation and permeability of the mold, proper ventilation is the remedy of eliminating open blows and blowholes. The cavities formed on the surface of the casting are called open blows, while those formed inside the casting are called blowholes. Molding material defects. These are the defects caused by the characteristics of molding materials. They are further classified into runout, fusion, cuts and washes. Runout is the leaking of molten metal out of the mold due to the faulty making of mold or faulty molding flask. Fusion is the brittle and glassy appearance on the casting product due to fusion of sand grains with the molten metal, caused by lower refractoriness of molding sand or very high temperature of the molten metal. This defect can be removed by selecting an appropriate type and amount of clay such as bentonite. Cuts and washes are the rough spot and area formed by excess metal present in the casting, caused due to the erosion of molding sand by flowing molten metal. This happens due to weak strength of molding sand or high speed of flowing molten metal. The former cause can be remedied by selecting proper molding sand and using appropriate molding method, whereas the latter cause can be remedied by increasing size of gates or using multiple ingates. Pouring metal defects. These are the defects caused by the properties of the molten metal being poured. These are further classified into slag inclusions. Misruns. When flux is added in the molten metal to avoid impurities and oxide formation in the hot molten metal, some of the slag formed by the flux enters the casting. This presence of slag in the casting product along with the molten metal is known as slag inclusion. Adoption of some of the slag trapping methods like pouring basin screens and runner extensions eliminates the possibility of slag inclusions. Misruns are caused due to the low fluidity of the molten metal and less thickness of the casting section. Misruns are formed when molten metal does not fill the mold cavity completely, thus leaving unfilled cavities. Misruns are eliminated by selecting proper casting design and by increasing fluidity of molten metal. Metallurgical defects. These are the defects caused by the properties of the casting product. These are further classified into hot tears and hot spots. Hot tears are unwanted cooling stresses developed in the casting product due to the poor casting design, which may cause the product to rupture. Hot spot is the formation of very hard white cast iron on the surface of casting made up of grey cast iron and small amounts of silicon due to chilling of the casting, that is, when the casting is cooled suddenly. The hot spots can be eliminated by adopting proper metallurgical control and chilling practices. Related term is print. Consider a casting product where a hole is present. In order to understand how this hollow product is made with core, let's remove the pattern and then place a sand core of shape identical to the desired hole in the cavity of the drag. You must be thinking how the core is kept hanging in the cavity without touching its walls. Let us understand how. For this, we take projections made on both sides of the wooden pattern by fixing two metallic pieces. The diameter of the rod is equal to that of the core. When the pattern is taken out of the mold, its projections leave impressions in the mold. Now we can easily fit the core in these impressions. These projections on the pattern are known as core prints, and they support the core to hang inside the mold cavity without touching its walls. Thus, core print is defined as the impression made in the mold by the projections of the pattern to support the core in the mold cavity. Related terms are in the solidification of metals and alloys. First, let's discuss the solidification of metals. when we pour the molten metal in the mold cavity. We see that the solidification process starts from the sides of the cavity, then moves towards the center of cavity. This is because the sides of the mold provide sufficient cooling to the molten metal. After some time, we see that the molten metal solidifies in the form of randomly oriented crystals. The region where the crystals are formed acts as the production area and is called the nucleus. When the molten metal solidifies further, we see that the shape of the crystals changes to a long columnar crystals. Having their axis perpendicular to the sides of the mold. Thus the shape of the molten metal crystals formed will be as shown. Note that during solidification of metals the temperature remains constant. This can be represented graphically as Now let's discuss the solidification of alloys. When we pour the molten alloy in the mold, we see that the solidification process takes place in the same manner as in case of solidification of metals. The only difference is that the crystals formed will have a dendritic structure as shown. Note that during solidification of alloys, the transition from liquid to solid state occurs during the change in temperature. This can be represented graphically as Thus we can say that solidification of metal results in the formation of long columnar crystals and solidification of alloy results in the formation of crystals having a dendritic structure. The related terms are continuous casting. Continuous casting is a casting process where a hot molten metal is poured into an open-ended mold to produce the casting product continuously. Let's understand this process with the help of an example. Consider the setup as shown. As we pour the molten steel from the ladle, we see that it gets collected in the refractory lined vessel called the tundish. We can see that tundish has multiple openings at its bottom and are connected to vertical copper molds. These molds are double-walled, bottomless and covered from all the vertical sides. At some distance below the top of each mold, there is a metallic starter bar which gets tightened between the passages. This starter bar is used to collect molten metal which will then drag it in the whole mold. Now release the molten steel from the tundish in such a way that it gets distributed evenly in each mold. We see that the starter bar remains at its original position till the molten steel fills the top of the mold. The molten steel freezes fast on the starter bar and on the surface of each mold. Thus, a solidified shell gets formed with liquid steel in it. After the molds get filled completely with the molten steel, withdraw the starter bar from each mold. Note that the rate of downward movement of the starter bar will be equal to the rate at which the molten metal is poured in the tundish. As a result, the starter bar and solidified shell move along a passage supported by the rollers. We can see that between the passages there are some spray guns which spray water on the passage to cool the solidified shell. We see that the shell keeps forming a casting product continuously till we keep pouring the molten steel into the tundish. Such process, which produces the casting product continuously, is known as continuous casting. Note that this casting product can be cut as per the desired length using the automatic cutting machines. Related terms are we know that in casting, as we pour the molten metal through the ladle, the metal flows across different elements before reaching the top of the riser. The section from the ladle till the riser is called the gating system. Thus, gating system refers to all the elements associated with the flow of molten metal from the ladle to the mold. The different elements associated with the gating system are pouring basin, sprue, runner, gate, and riser. Now let us briefly describe each of these elements. Pouring basin acts as a reservoir. It collects the molten metal which is poured from the ladle. Note that one of its wall is inclined about 45 degrees to the horizontal in order to absorb metal momentum and to prevent vortex formation. Also note that the pouring basin should be filled completely with the molten metal in order to prevent the formation of funnel. Sprue is a vertical channel through which the molten metal comes in contact with the parting line from where it enters the runner and the gate to reach the mold cavity. Note that the channel is tapered at the bottom in order to provide low pressure area to the molten metal. Runner is a horizontal channel located at the parting line to allow molten metal to flow smoothly from the sprue to the mold cavity. Gate is a small opening through which the molten metal enters the mold cavity. Note that gate should be designed in such a way that it can be broken easily after the casting solidifies. And riser is a reservoir of molten metal. It is used to feed the casting during the solidification process in order to prevent the formation of shrinkage cavities. Process. Casting is a process which involves pouring of hot molten metal into a mold cavity and then allowing it to solidify to obtain the casting product. To understand the casting process, let us make this material through casting. First, place a wooden board on the table, and then place a wooden flask on the board. Now at the center of the flask, place a wooden workpiece. Note that this workpiece is called the pattern, and it is the replica of the product to be produced. Now sprinkle some parting sand in and around the pattern. Then place a hand riddle on top of the flask. Now put some sand in this riddle and then filter the sand. Note that the filtered sand is called the facing sand. Now remove the riddle and put some more sand in the flask till it gets filled completely. Note that the sand which we had put after removing the riddle is called the backing sand. Now take a hand rammer and ram the sand so that the sand inside the flask gets compressed and compact. Then use a strike-off bar to level the sand equally. Note that this flask which contains the sand and pattern is called the mold. Now turn this flask and place another wooden flask over the previous flask. Then place another similar pattern over the first pattern. And repeat the same procedure, that is, sprinkle the parting sand. Then place a hand riddle and put some sand and filter it. Then remove the riddle and put some backing sand. And then ram the sand with the hand hammer and level the sand equally. Note that now this upper flask is called the cope and the lower flask is called the drag. Now place the cope and drag aside. Then lift the cope and place it upside down. Now in this cope make a tapered hole with the sprue cutter and a straight hole with the plain cylindrical rod. Note that the tapered hole is called the sprue and the straight hole is called the riser. Then use the draw spike to pick the pattern out of the sand from the drag and cope. The shape left in the mold is called the cavity. Then make a passage between these holes and cavity with the help of a spoon slick. Note that the passage which connects the sprue and cavity is called the runner and is used to guide the molten metal flow into the cavity. Now in this cavity insert a vent wire to make a hole in order to release the hot unused gases. Now inside the cavity of the drag, place a cylindrical object made of clay. Note that this object is called the core and is used to produce the hollow work pieces. Then place the cope again on top of the drag. As we can see that this tapered hole is too narrow for the proper flow of molten metal. So make a larger basin beside the tapered hole and connect them through a passage. Note that this larger basin is called the pouring basin. Now with the help of the hand ladle, keep pouring the molten metal in the pouring basin till the molten metal reaches the edge of the riser. Now allow the molten metal to solidify in the mold. Now take the material out of the mold. We get the product as. This product is called casting product. Some of the common products which we obtain through the casting are wheel, piston, bells, etc. Related terms are pattern materials used. The pattern used for casting is mainly made up of wood, metal and plastic. Wood pattern is mainly used to produce large casting. It is commonly used pattern due to the following advantages. It is easily available, its weight is light, it can be easily shaped and is cheaper. But the main disadvantage it possesses is that it easily absorbs moisture from the sand. Note that most flat patterns are made up of wood and the wood used in wood pattern is the mahogany. Metal pattern is used when large number of casting needs to be produced and also when the molding sand is abrasive in nature. Some of the advantages of metal pattern are as follows. It has high durability. It has smooth surface finish and has closer dimensional tolerance. The metals used for metal pattern are aluminium alloys, grey cast iron, brass and bronze. The table shows the advantages and disadvantages of these metals. Plastic pattern. The advantages offered by plastic pattern are as follows. Its weight is light. It can be easily formed. It has smooth surface and high durability. Can be easily cleaned and does not absorb moisture. The most general plastic used for making plastic pattern is the cold setting epoxy resin by adding suitable fillers. Note that polyurethane foam is also another type of plastic material used for making plastic pattern. It is mainly used to make patterns for a special casting process, that is in full mold casting. Related terms are. How is its size determined? In casting, riser plays an important role during the solidification process. It acts as a reservoir and feeds casting during the solidification process in order to prevent the formation of shrinkage cavities. To determine the size of the riser, we need to know the freezing ratio. So let's discuss what freezing ratio is. Consider the molten metal solidified in the riser and in casting. The solidified metal in both the riser and casting has a surface area and a volume as well. If we take the ratio between the surface area and volume of these solidified metals, this will give their respective cooling characteristics. The ratio between the cooling characteristics of casting and that of riser is called the freezing ratio. It represents how fast a casting solidifies relative to the riser. Note that for optimum casting the freezing ratio should be greater than unity. We can determine the size of the riser with the help of freezing ratio X, and thus using the formula given by scientist Kane. Mathematically, Kane's equation is expressed as where X is the freezing ratio, Y the ratio between the volume of the riser and that of casting, and A, B, C are the constants for the casting material. Thus we can say that riser acts as a reservoir for the molten metal. It feeds the molten metal to the casting during the solidification process to prevent the formation of shrinkage cavities. Its size is determined with the help of freezing ratio and the given dimensions of casting. What are the types of cores? Consider a casting product where a hole is present. In order to understand how this hollow product is made with core, let's remove the pattern and place a sand core of shape identical to the desired hole in its cavity. So now, when the molten metal is poured in the cavity, the core prevents the metal from flowing into the volume being occupied by it. Thus, the molten metal fills the entire cavity, but not the region occupied by the core. Thus, core can be used to make holes or internal cavities in casting products. Thus, core is a sand object used to make holes, internal cavities or hollow projections in casting. The main characteristics of a core are: the different types of cores are green sand cores. They are the cores that are obtained from the pattern in the molding process. Dry sand cores. They are the cores that are obtained from special core sands in a separate core box, baked and then finally kept in the mold before pouring of molten metal. Some of the types of dry sand cores are unbalanced core, balanced core, cover core, vertical core and drop core. Note that core also absorbs the heat released by the molten metal surrounding it. Related terms are die casting is a special casting process where the molten metal is injected under high pressure into the mold cavity formed by a set of reusable metallic dies. To understand how die casting is performed, consider the setup as shown. As we can see, the setup consists of two metallic dies, where one of them is fixed and the other is movable. The fixed die is called the stationary die, and the movable die is called the ejector die. The stationary die is further connected to a vessel via pipe. Then spray the hot lubricant in the cavities of the die with the help of a spray gun. Now remove the spray gun and move the ejector die towards the stationary die. Then open the valve of the vessel to allow the molten metal to fill the pipe. When the pipe gets filled completely, close the valve. Now apply some pressure on the molten metal. Due to pressure, the molten metal gets injected into the space of the mold cavity formed between the dies. Now allow the molten metal to cool for some time. Then remove the ejector die. We see that the solidified casting sticks to the ejector die. Remove this casting with the help of ejector pins. We see that in this casting, unnecessary projections are also joined. So, to get the desired casting cut, these projections. Thus we get the desired casting as. Some of the examples where die casting is employed are carburetor, handlebar, and propeller. Note that stationary die is also called a cover die, as it acts as a cover for the molten metal. Related terms are